guys, so today we're going to be looking at what are quadratics and what do they look like and how to solve quadratics and everything to do with quadratics. So what is a quadratic? A quadratic is a polynomial, it's an algebraic expression, but what does it look like? Okay, so first things first, what does it not look like? If we look at a linear equation or a linear expression, that will look like something like this. Okay, you may recognize this from y equals mx plus c, which you recognize as the straight line graph. But what makes this a linear equation or a linear expression is that the power of x has a maximum of 1. Remember here, even though there's no number, it has a maximum power of 1. So that is a linear expression. That's the one before a quadratic. And as the name suggests, and as I just mentioned, it kind of represents a straight line. Okay, so what does a quadratic look like? It's a polynomial where the power of x can be up to a maximum of 2. Okay, so what will our equations look like? It will look in this kind of format where you've got a number in front of x squared, a number in front of x, and then a plus c. Okay, a constant term there. And what would that look like on a graph? Well, we know that a linear line looks like a line. Whereas an expression like this, if we were to plot that on a graph plotting x and y, it would look something like that, which is known as a parabola, or as I tend to call in my classes, a smiley face. Okay, to look into that a little bit deeper, we're going to look at Desmos now. Okay, now on Desmos, what I've created here is an expression or an equation, because it's equal to y equals ax squared plus bx plus c, where a can change and b can change and c can change. Okay, so at the moment all the values are 0, and all we can see on our grid is this straight line that goes through 0. Okay, thinking about what this actually means, y represents the height per se of this grid. Okay, so as x is going along, the height at the moment is just 0 plus 0 plus 0, so there is no height. So it's just a straight line that goes across there. Okay, when you're looking at linear equations, then I'm going to keep ax squared as 0, so there's no x squared. We're just looking at the bx and the c. So what happens, first of all, if I adjust the c, you can see now, as I increase it, the line just kind of increases. Okay, so say for example, when c is 5, so if it's y equals 0 plus 0 plus 5, that's just a straight line that goes through the coordinate 5 right there. Okay, now the next thing to look at is what happens when we adjust b. Okay, so if there's now a number in front of x, what happens if I increase that? And you can see this time the line gets what's called a gradient. Hence, when you should recognize that from y equals mx plus c, when the number in front of x goes up, it gets steeper and steeper and steeper. And then when x goes down, so if x is 0, going back to 0, you can see there now it's just that straight flat line again. Now if b is negative, you can see it's now sloping the other way around. So in effect, the height is now negative. As x goes across, your height becomes more and more negative. Okay, let's take that back down to 1. Let's keep that to 0 for now. Let's keep our y-intercept 0 as well. And now we're going to look at, so what happens when we adjust the a? So now we're going to introduce what happens when it's squared, and you'll see quite a dramatic change straight away. When you increase, so even if there's a tiny number in front of x squared, you can see it instantly turns into this parabolic shape. It's a parabola, or as I like to call a smiley face. Okay, and as that gets bigger and bigger, you can see it kind of squishes that graph along the axes. And then what happens as it goes lower and lower and lower, so back down towards 0. So if a is 0, there's no x squared, we're back to that straight line again. And if a is negative, as it goes down, you can see it's an unhappy face. And as that gets lower and lower, it becomes more of a frown, I guess. So you can see that this has quite an effect. So all the different quadratics, as you change those numbers along, they have an effect on the shape and the placement of the graph. And it's important that you kind of keep an image of what a quadratic looks like in your heads, so that you can, when you're solving problems, you can kind of see what you're actually, you can picture in your mind's eye what you're actually working out. So what we're going to be looking at now is how to solve a quadratic by factorizing. Okay, now what does it mean to factorize something? Okay, in terms of algebra, what we want to try and create is brackets. So when you're factorizing, you're trying to think of things that divide into a value. So I want to think, how can I split this up into something times something else? Okay, and the way that would look, it would look like a double bracket. So if I start that, I want to make this expression look like double brackets. Okay, it's going to have a plus or minus something times a plus or minus something. Okay, now to work that out, the first thing I want to do, okay, is think about what happens when it's not expanded, sorry, not factorized, it's the expanded format. Okay, so if I have a and plus something, I'm going to say plus x there, times a and plus something. Okay, if I multiply these two together, there's 4 calculations, and you should know from when you're expanding brackets, you can kind of simply do this by multiplying the first number by both of those and the second one by both of those. Using a grid, it just kind of makes that a little bit easier. So I'm going to do a times a, which gives me a squared. And then I want to do a times this, whatever that is, so it'll be ax, a times x. You're going to have another a times x, and then x squared. And notice when you simplify this, these two terms can add together. So it's going to look in the format a squared plus 2ax plus x squared in this case. Okay. Now, in order to work this out, so if I kind of go backwards on this grid, okay, so I'm going to take away what we were doing there to show you what it looks like when it's expanded, and I'm going to try and figure out from this expanded version, okay, from here, if I put those values back into my grid, well, the a squared sits up there, the minus 28 would go down to the bottom there, and these two values would have to add up to plus 3. Okay, so we can see to get a squared, there's only one real simple way of doing that, that's a times a. So I've got the first part of my bracket sorted. Okay, so now I need two values here that multiply to minus 28, but they add to 3. And you can use a bit of trial and error. You can think of what are the factors of 28. Okay, 1 and 28 multiplies to 8, but you can't make 3 out of them, so that's no use. Okay, 2 goes into 28, it goes 2 times 14. Again, I can't make 3 out of them by adding and subtracting, so that wouldn't work. Okay, 3 doesn't go into 28, but 4 does. 4 times 7. And you can see 4 and 7, so if I put that there and there, that will give me 7a and 4a. And you can make 3 out of them by subtracting. And you've got to choose which one is it going to be. Am I going to take away the 7 or am I going to take away the 4? Well, this is a plus 3. So in order for that to stay positive, that means I'd have to do minus 4 plus 7 to give me the 3. And now I've worked out those two numbers. So it's a minus 4 and a plus 7. And that will give me what I need in my brackets. So it'll be a plus 7 and a minus 4. Now, that's the actual factorizing part done. And what I want to do now is I want to use this to solve. Okay, so if I know it's a plus 7 times a minus 4, and that is equal to 0, making it equal to 0 is a really important thing to do. Before you can solve a quadratic equation, you normally want to make it equal to 0. Okay, because that has an interesting property. If two things, now here we've got two brackets, Okay, if I label this bracket A, in fact, let's use a different letter because we're using A. Let's call this bracket M and this bracket N. Okay, if they multiply together to give me 0, that means one of those has to equal to 0. So that means that either A plus 7 is equal to 0 or A minus 4 is equal to 0. Okay, thinking about it, if two numbers multiply to give you 0, one of them has to be 0. And you think of any numbers that you can multiply together that equals 0 where one of them is not 0. It can't be done. So that means either this one or this one equals 0. And then using that, solving that simply, if I subtract 7 from both sides, or if I move the plus 7 over, that becomes A is minus 7. And if I do the same thing here, A is minus 4. Okay? Does that mean that there are two solutions? Absolutely. When you square root anything, because ultimately we're going from a squared value to a non-squared value, when you square root something, so say for example if I had the square root of 25, the answer isn't just 5. I know that 5 times 5 gives me 25, but it could also be minus 5, because minus 5 times minus 5 will give you plus 25. So that's why there's two answers or two solutions in this case. Okay, when you do this in context, if it's to do with area, you don't want to include, I just realized that should be plus. Okay, when you're solving this and it's in a context where you're working out an area, then you would discard this answer. That's not important. It's not minus 7. A would be 4 in this case. Okay, and going back to what the quadratic looks like, this tells us a lot about the shape of the graph. What we've actually worked out here is called the roots of the equation. Okay, if I look at it on a grid now, I know now at minus 7, that's when it's equal to 0, and at plus 4 it's equal to 0. So it's kind of told me just through a little sketch that that is what my graph will look like. Okay, a little handy hint here as well, you can also tell, because it's in this format, the minus 28, that point there would be minus 28. And so you can see what our graph will look like. So when you're solving a quadratic, what you're working out is actually the roots of the equation. Where is this parabola, where's this smiley face crossing the x-axis there? Or in this case, there would be the a-axis actually, because here we're plotting A, and then that's equal to something else which we would call Y. But yeah, so we worked out when A is 4 and when A is minus 7, that's where this parabola crosses the axes. Okay, what we're going to be looking at next is how to solve a quadratic in this format. Okay, if you notice first, it says give your solutions correct to 3 significant figures. This is a clue that tells you that this will not be factorized, so it can't be factorized here. Okay, why is that a clue that has been factorized? Well, can you think of a time where you've got anything like a plus 1.72 to 3 significant figures and say a plus 1.15 or something like that? Factorizing that would be extremely difficult, so we can't use that method to solve this quadratic. What we can do, however, is use something called the quadratic formula. Okay, that quadratic formula is given to you in your exams these days. Okay, but I pretty much can imagine by the time you get to your exams you will have memorized this minus b plus or minus the square root of b squared minus 4ac over 2a. Notice that the plus minus, you only ever do one at a time. You either do plus or you do minus. That doesn't mean you do both at the same time. Okay, so how do we use this formula? Well, as we've mentioned before, all quadratic expressions can look up to this format. That's not to say that there's always a b. It might be, for example, 3x squared plus 7 equals 0, and that just means that b equals 0 in that case. Okay, but it will always be in that format. Okay, so first things to notice, the number in front of A, okay, let's change that to red to keep our color scheme going. Okay, the number in front of A, or the coefficient, so which just means the number in front of x squared, will be 3 in this case. So A is 3. Okay, the number in front of x is B. So in this case, don't forget to include the minus there. So B is minus 11. And then your plus C, the constant there's no x attached to it. The number that's on its own, again, in this case, it's negative. C would be minus 13. So the first thing you want to do is substitute those values into this formula. So this is telling me that x, so if I start this off, x equals, and it's going to be minus b. So I want to do minus whatever b is. In this case, it's minus 11. And notice that I wrap any negatives in brackets. It only really makes a difference if you're raising that to an even power, okay? But it's important that when you tap this into your calculator, you must wrap any negative numbers in brackets. So it'll be minus b, and then it's going to be plus or minus the square root of, and then b again, b squared. And this is where it's really important. If you don't wrap this negative, so I've written the negative out in brackets first and then squared it, okay? It's really important to do that, because otherwise your calculator is so smart, it will do BIDMAS, it will do 11 squared and then take it away. Wrapping in brackets avoids doing that. And that needs to be multiplied 4. So take away 4 times A and C. There'll be 4 times A, which is 3. And that's going to be multiplied by C, which is minus 13. And again, I don't actually need to wrap this one in brackets, but it's a good habit to be in. Anytime you put a negative on your calculator, you wrap it in brackets. So let's just neaten that up. That's going to be all over, that's divided by 2a. So it's going to be 2 times a, which was 3. So this is the equation that I need to put, or the expression that I need to put into my calculator. So if I put my answers in now, so let me grab my calculator. So first things first, let's get this on the right format, okay? When you start this off, start off with your fraction button, okay? If you don't have a Casio calculator, this might be a bit more difficult and it will involve more steps, but I'd advise you to get this calculator, especially this one in particular. You'll recognize this one, it's got the code 991 and it's got a silver button here. I'm going to show you another way of solving quadratics on this, which makes life a lot easier. But to enter this into your calculator, I'm going to start off with, so minus 11. And you know, most of you will realize that you could actually just type that in as plus 11, because minus 11 is just plus 11, but I like to be a bit more meticulous with my working. So I'm going to start off with plus. Now you're going to use plus and minus, but you do those separately. So plus, and then the square root of, and again, this is so important that the minus 11 is wrapped in brackets and then it's squared. If you don't do that, it will make sure that your answer will be wrong. So it's so important, wrap your minus 11 in brackets, minus 4 times 3 times, and again, this one doesn't need to be in brackets, but I just like to make sure and be thorough, okay? And then use your arrow keys to move down to the bottom bit, 2 times 3. And when you press equals, first of all, it will give you your answer, and this is called insert format using the square root sign there. But if you press this button, S to D, that changes from surd to decimal. And that's our first answer. So our first answer will be 4.607. And notice I've given that to more than 3 significant figures, but we'll come back to that. So that was my first answer. My second answer, now if you're really efficient with your calculator, you can use the arrow keys. If you press forward and work your way to the plus, press delete and change that to a minus. Now it gives you your second answer, which is minus 0.9405. So minus 0.9405. Okay, we're almost done here, but this needs to be to 3 significant figures. Okay, so if I look at the third significant figure, so the 4 is the first, second, that's your third significant figures. Will that stay a 0? Well, it's got a 7 next to it, so that tells me I need to round up. So actually, that would be 4.61. So we write x equals 4.61. And that's one of my answers. Okay, similarly with this one, this 0 is not significant. Your first non-zero value is your first significant figure. So this is my first one, second significant figure. Now this 0 is significant because it's not a non-zero value and it's between significant figures. This is my third significant figure. And again, it's got 5 next to it, which means it rounds up. So my other answer will be x equals minus 0.941. Now, as I mentioned before, if you've got this calculator, which I recommend for all A-level and GCSE students, okay, it's the one with the silver button, it's called the 991. You have a function here, so if you press your menu button, okay, you go over to A, which is equations or functions, press equals, and what we want to solve, you can do simultaneous equations or you can do a polynomial. Okay, now my polynomial, in this case it's a quadratic, so it's got a maximum power of 2, so I want to select 2, and it allows me to enter my values. So if I start off with, in this case it's 3x squared, and you press equals as you go along. The next one, it will be minus, so press minus 11 equals, and then the third value will be minus 13. This is really handy because if I press equals now, it tells me immediately what my first answer was. If I press equals again, it tells you immediately what your second answer should be. And it's also got a handy function where it tells you where the x, so in this case that's the x value for your minimum point. Remembering what our graph looks like, okay? In this case, if I sketch this graph, I know my roots are 4.61 and minus 0.9. So that's what my graph will look like. And this function, this calculator is telling me that my x value for the minimum point, so that point there, my x value, my first coordinate will be 1.83, and my second one, if I press equals again, my y coordinate will be minus 23. So again, it tells you quite a lot about the function itself, so minus 23 point something. Okay, so using your calculator is really useful in order to use the quadratic formula. And if you've got this one, which you're allowed in your GCSE and your A-level exams, I would strongly advise you to use the calculator efficiently, making sure you can use your fraction button and any other buttons that you need to work these out. Okay, so this is a harder quadratic equation to solve. Okay, now when you see a number in front of x squared, that should kind of tell you should use the quadratic formula, even though it doesn't say give your answer to some decimal places or to 3 significant figures, for example. Okay, in this case, I think you are able to factorize it, or you can use the formula. Okay, just to show you, if you're going to use factorizing, there's 2 main methods that I always teach on how to factorize when the number in front of x squared is bigger than 1. If there's no number in front of x squared, it's really easy. You just find 2 numbers that multiply to this and add to that. But in this case, that won't work because one of those numbers has to be multiplied by 5. Okay, so the first method is using what I call a grid, the grid method. Okay, when you expand out brackets, you've got 2 things here. So it's a binomial here. So if you imagine in double brackets, you're going to have, in this case, x, or it would be 5x times something, and x times something. Because x, the 5 is a prime, it can only be 1 and 5x. So that's what belongs there. Okay, I've to figure those out, so I know it's going to be x times 5x. Okay, I don't know what these two terms are. These are the ones that I'm trying to work out. But from the equation, I can tell that the minus 12, I also need two numbers that multiply to minus 12. But when I add these two up, they add up to 11. Okay, so let's think about these two numbers that multiply to 12. They can either be 1 times 12, 2 times 6, or 3 times 4. Those are all the factors of 12. So I've got to choose each one. So I'm going to try it one by one just to show you. Sometimes you can start to figure out and use a bit of trial and error and guessing. Okay, but if I use 1x and 12x, so 1 and 12, if I multiply those, x times 12 is 12x, 1 times 5x. Now the problem there is that they don't add up to 11. Okay, so I'll try them the other way around first, see if that works. So instead of 1 there, I'm going to put the 12 there and the 1 there, but still that gives me 1x and 60x, which again definitely doesn't add up to 11. So it can't be those two. Okay, so using trial and error again, I could try the 2 and the 6, but I'm going to go straight onto the 3 and 4. Okay, so if I put the 4 there and the 3 there, again you can see 4 times 5x will give me 20x. These don't add up to 11. But if I try them the other way around now, this time put the 3 there and the 4 there, 4 times x gives me 4x, 3 times 5x gives me 15x. And you can see now, out of 15 and 4x, I can make 11 if I subtract. So to make it plus 11, I would need to take away the 4x, which makes that minus 4. And that has worked out now on the outside what my two brackets are. So what I'm actually trying to solve is 5x minus 4 in one bracket and x plus 3 in the other bracket. Now, to solve it from here, the same kind of thing. If two brackets multiply to give you equals 0, that means one of these two brackets has to equal 0. So either this one, so either 5x minus 4 equals 0, or x plus 3, the second bracket, is equal to 0. And if you solve those using just the normal linear method of solving equation, so add 4 to both sides, or move the 4 to the other side, and then divide both sides by 5, we get x equals 4/5. So that's one of the solutions. Or in this case, if x plus 3 equals 0, move the 3 to the other side, so we get x equals minus 3. So that's one way of factorizing it. Okay. There's another method. When the number in front of x squared is bigger than 1, you can use what's known as the AC method. Okay. The reason why it's called the AC method, remembering that all quadratics are in the format ax squared plus bx plus c equals 0. Okay, I want to first start by multiplying together the coefficient of x squared, which is a, and the c. So if I start off with my equation, 5x squared plus 11x minus 12. Okay, if I multiply those two numbers together, that gives me minus 60. Okay, now what I need to find now are two numbers that multiply to minus 60 but add to 11. Okay, now the factors of 60, it can be 1 times 60. I can't make 11 out of those two. It could be 2 times 30. Again, that won't give me 11. 3 goes into 60, so 3 times 20. That won't give me 11. 4 times 15, however, which is the next one, 4 and 15 you can make 11 out of, and because it's minus 60, that means one of these two has to be a negative. In this case, because it's plus 11, that means the 15 will be positive, because it will be 15 minus 4 to give you plus 11. So I found my two numbers, and it's also known as the splitting the middle term method, because now what I'm going to do here is I'm going to split that plus 11x into those two numbers. So if I write 5x squared minus 4x, and then the other one's going to be plus 15x minus 12. Okay, so if you notice, getting those two numbers, I've split that 11x into both of those two values. So instead of 11x, I've got minus 4x plus 15x. If I put a little line down the middle, what you want to do now is either side of that line of your split value, factorize each side. On this side, I can take x out. So if I take x out and open a bracket, that leaves me with 5x minus 4. Okay, on this side, what comes out now, they're both divisible by 3, so if I could take out plus 3, if I divide those both by 3 now, 15x divided by 3 is 5x, minus 12 divided by 3 is minus 4. You'll know you're doing this right if both your brackets are the same. If they're not the same, then you know you've made a mistake somewhere. And then the last step is to factorize once more. They both have the bracket in common. So if I take that bracket out, what's left on the outside will be my second bracket. So that's another way. So you've got two ways of factorizing to solve that. Okay. Again, the same method here, either 5x minus 4 equals 0, so x would be 4/5, or if x plus 3 equals 0, then x is minus 3. Now, if you find this really difficult and you're adamant that you can't factorize when the number in front of x squared is bigger than 5, I can show you another method using the quadratic formula that still allows you to factorize. So I'm going to pretend that I'm solving this by using the quadratic formula. Okay, so let's get rid of that. If I use the quadratic formula, here a is 5, a is 5, the number in front of x squared is always a, the number in front of x is b, that will be my b value, so it's plus 11, and my c in this case will be minus 12. And remembering our quadratic formula, so if I do minus b plus or minus the square root of b squared minus 4ac all over 2a, okay? If I substitute my values in, so in this case it's going to be minus b, so minus 11 in this case, so minus 11 plus or minus the square root of b squared, which is 11 squared, minus 4 times a and c, so a is 5 times c, which is minus 12. Remember, you don't actually need to put in brackets in this case, but I always like to be very thorough and always put negatives and brackets when I'm using a calculator. And then I need to divide that by 2 times a, which is 5. Now, if you work that out, so if I plug that into my calculator, so always start with the fraction button first. The fraction button, so in this case it's going to be minus 11 plus the square root of 11 squared minus 4 times 5 times minus 13. Remember, it doesn't actually need to be brackets because you're not squaring it. It doesn't matter if you put the brackets in. I just like to be a bit thorough, so that should be minus 12. And then that's going to be divided by 2 times 5. And if you press that, it gives you your first answer, x equals 4/5. If you leave it in fractional form, I'll show you why this is useful. So x equals 4/5. Or, and remember you need to change it into negative as well. So using my forward key, I'm going to change that plus to a minus to give me my second answer, so x equals minus 3. Now, even if I needed to factorize to solve this, so if the question said solve by factorizing, this would only get me 1 mark, because while the answer is correct, the working was incorrect. But to factorize using your answers, okay, this is a bit of a cheat method here, okay, I'm going to go backwards from here. So if x is 4/5, if I times both sides by 5 to get rid of the fraction, that gives me 5x equals 4, and then make it equal to 0 by moving the 4 to the other side. So we get 5x minus 4 equals 0. That's my first bracket. So now I can write my bracket 5x minus 4. Do the same thing here. If x equals minus 3, make it equal to 0 again. So x plus 3 equals 0. That would be my second bracket. And now, even if it said solve by factorizing, because I've shown that I've factorized it, even though I've done this method, that will still enable me to get my full marks because I've factorized it and I've solved it. So it's a little bit of a cheat there. You can use your solution, you can use the quadratic formula. Where this could be really handy is if you're doing something like algebraic fractions and you're not sure how to factorize, or you're not sure whether you've done it correctly. By using the quadratic formula and then working backwards, you can always factorize. And it's especially useful for those people that have got this calculator, where you're able to use the quadratic formula without even using the formula. So you could actually just enter your values in, get your answers, and then use this method of working backwards to work out your brackets. So it's a really useful way of solving quadratic equations. Okay, the next thing that we're looking at is solving using a different method, okay? And the clue that's given in the question, it says write this in this format, where a and b are constants, so they are just numbers. A is just a number, b is just a number, okay? Now, what this is called, this format is called completing the square. Okay, if I want to write this in a completed square format, okay, first of all, let's think about what's happened here, okay? If you've got x plus something squared, okay, just to give you a few examples here, if I tried x plus 1 squared, when expanded out, that would give me x squared plus 2x plus 1. If I did the same thing for x plus 2 squared, that would be x squared plus 4x plus 4. If I had, say, and I'm going to use a negative here, x minus 3 squared, that would give us x squared minus 6x, and then minus 3 squared would be plus 9. Okay, now if you notice, the number, when it's expanded there, has a relationship with the number in the bracket. Every time it's double. So if I use that in this case, for x squared plus 12x, I'm going to start this off with x plus, and then whatever that is, I'm going to half it. So it'll be x plus 6 squared. Now that will, if I expand this out, that will not get me, even if I had the minus 1, okay, that's not going to be the same as those two, and I'll show you why. Because if I do x plus 6 squared, when expanded out, that gives me x squared plus 12x. So we've got the first bit correct. So we've got that bit, which is fine. But we don't, when we expand it out fully, we get plus 36. And we don't want this plus 36. So in effect, whatever number that goes in that bracket, that number squared, I need to get rid of. Okay? So in this case, because the number was a 6, I need to minus the 36. And now that is the completed square format. So if I simplify that, that gets me x plus 6 squared minus 1 minus 36 is minus 37. And now it's in that format where a is 6 and b is minus 37. Okay? You can also use this to solve an equation, because if I wanted to solve, for example, x squared plus 12x minus 1 equals 0. If I was to solve that, I can complete the square. So remember, we half the number in front of, or half b, the number in front of x. So it'll be x plus 6 squared. And then I've already got the minus 1, but I want to take away the number in the bracket squared. So minus 6 squared, and that will equal to 0. So once we've got it in the completed square format like that, so minus 37 minus 1 minus 36, okay, I can now solve this using the balancing normal solving equation method. So if I add 37 to both sides, I get x plus 6 squared equals 37. Square root both sides to get rid of the squared there. So I'm left with x plus 6 equals the square root of 37, remembering that it can be plus or minus the square root of 37, okay, and then subtract 6, and I can write my answer in the format minus 6 plus or minus root 37. So when you see a question where it says leave it in this format, or if it says leave your answer in the format a plus root b, okay, it's telling you that it wants you to complete the square to solve this question, and you'll be able to get it in third form like that. Alternatively, you can use the quadratic formula and it will give you your answer on the calculator in a third format as well. But this method is particularly useful actually because it also tells you where the minimum point. So we know now, if I work out what these values actually are, so if I do minus 6 plus the square root of 37 equals, that gives me 0.08. So one of my solutions is 0.08, and one of the solutions, so if I change that to minus, so minus 6 minus the square root of 37, that'll give me minus 12.08, so minus 12.1. Okay, remember these are the roots of the equation, so I can work out from there that at 0.08 and minus 12.1, so if that's minus 12 and that's 0.08, that's what my graph will look like. And the completed square format, so where I've got it written here, x plus 6 squared minus 37, okay, the number in the bracket, okay, the opposite of that, so instead of plus 6, minus 6 will be your x value for the minimum point. So that's minus 6 right there, and then the minus 37 tells you your y coordinate. So what that enables us to do is to learn that my minimum point will be minus 6 minus 37. So the key thing to notice there, once you've got it in completed square format, that number there, the opposite of that, so instead of plus 6, I've got minus 6 and minus 37. So just to give you another example, if I was to do, for example, if I had x plus, in fact, let's do a minus 1. So if I had x minus 5 squared minus 22, when I completed the square, okay, that's telling me, without working it out, that my coordinates for the minimum point there will be positive 5, because it's the opposite in there, so it'll be positive 5, and this stays the same, so minus 22. So if I look at those coordinates, 5 and minus 22, that's what my graph will look like. Okay, so the next thing we're going to be looking at is solving a quadratic inequality. Okay, so notice this is just like a quadratic equation, but instead of an equal sign, you've got either a greater than or a less than sign. In this case, the equation is greater than 0. So to solve this, our first step is pretty similar to solving a quadratic. We need to find the roots of the equation. So I need to solve x squared minus x minus 12 equals 0. Okay, so if I work this out first, this one's a nice and easy one to factorize. So because there's no number in front of x squared, I need to find two numbers that multiply to minus 12 but add to minus 1, remembering that's the 1 in front of there. So if I think about the factors of 12, 1 and 12, you can't make 1 out of those. 2 times 6 gives me 12. Again, I can't make 1 out of those. But 3 and 4, okay, they multiply to 12, and you can add, so you can subtract one of them to make it add to minus 1. Okay, in this case, because it's a minus 1, that means it's going to be 3 take away 4. So 3 times 4 minus 4 gives us minus 12, and it adds to that. So I can factorize that nice and easily. Now it will be x plus 3, and then x minus 4 equals 0. So my roots of the equations are going to be x equals minus 3, because it's the opposite of there. Remembering, if x plus 3 equals 0, then x is minus 3. If x minus 4 equals 0, then x equals positive 4. So I've got my two roots for the equation, but that's not the actual solution, and it's not as simple as just rewriting that with your inequality sign, and you'll see why. Remembering that when we work this out, we are working out the roots of where it crosses your x-axis. So I know it crosses at minus 3 and at positive 4. So that's what my graph will look like. And what I want to know is, when does this graph, so that represents the blue line there, the graph, when is that bigger than 0? So meaning, when is the height of this graph, because it's equal to whatever the height is, okay? You can see from here, it's above 0 at this point here, and at this point here. When it's underneath that line, it is less than 0. So using that fact now, I can figure out that actually this graph, this blue line, is above 0 when x is less than minus 3, because that will carry on all the way down minus 4, minus 5, etc. So when x is less than minus 3, or when x is bigger than 4. So if x was 5, it'd be above the line. If x was 6, it'd be above the line. Yeah, so when x is bigger than 4. So those are my two solutions using quadratic inequalities. It's so important to use a sketch of the graph to try and help you to work this out. Okay, notice again, if x was 1, for example, you can see it would be less than 0. It'd be below that line there. Okay, so we wanted to find when it's bigger than 0. Okay, in a similar format. Okay, so this time I've got a harder equation and it's less than 0. Okay, so same first step, we find the roots of the equation, and again you can either use the quadratic formula or you can factorize. I'm going to factorize. I'm going to show you again how to use the grid method. So from the equation, the 2x squared belongs there, the plus 9 belongs there. Okay, and I need to figure out what these two are, but I know that they need to add to minus 11. And this one's not too bad, because 2x squared, again, that's a prime number. Only 2x times 1x can give you 2x. Now to make the 9, it can either be 1 times 9 or 3 times 3. Okay, I'm going to try the 3 times 3 first. So if I do that, that gives me 6x and 3x. Does that, am I able to add those or subtract those to make 11? I'm not, so that was the wrong one to use. If I use 1 and 9 then, so if I put the 9 there and the 1 there, 9 times x is 9x, 1 times 2x gives me 2x. And you can see there, you can make 11, 9x and 2x makes 11x, but it needs to be minus 11, yet they multiply to a plus, which is telling me then both of these need to be negative. So I've worked out my two brackets there, 2x minus 9 and x minus 1. And remember, I'm working out the roots to the equation. So if I solve this, either 2x minus 9 equals 0 or x minus 1 equals 0. If it's this one, if I add 9 to both sides and then divide by 2, 9 divided by 2 equals 4.5. So that's one of my roots. Or on this side, if x minus 1 equals 0, x equals 1. And remember, this isn't solving the inequality, and it's not as simple as me just replacing that with the inequality sign. I've got to figure out which way it's facing. Okay? So if I put my roots into a set of axes, so when x equals 1 and x equals 4.5, that's what my graph will look like. So again, this pink line here represents the actual equation, and we want to know, when is this equation above the line? When is it above 0? Because that line represents 0. When is it above 0? Well, in this case, it's when is it lower than 0? This time, I need to know, when is it below the line? So actually, anywhere here, so if x was 2, it'd be below the line. If x was 3, it'd be below the line. If it was x is 5, it'd be above the line. So I need to know that x has to be between these two values. So that means x must be bigger than 1, or x must be less than 4.5. And you can combine those into one inequality. So writing it like this, the arrows will always face the same way. X is bigger than 1, and x is less than 4.5. And that's how you solve quadratic inequalities. It's so important to use your graph. So you solve it normally like an equation, and you work out your roots, and then you've got to decide, am I using the space in between where that's below the line, or am I looking at the bit that is outside the line, that's above the line?